Hello everyone, my name is Suleman and today I will be talking a little bit about the types of failures and basic concepts of fracture mechanics. To begin, failure of a material is when a material breaks due to a remote force and does not satisfy its function. In this course, we mainly focus on three main types of static loading, which includes impact, fatigue, and surface wear. Now, static loading can result by large deflection or plastic distortion and fracture. Moreover, failure is defined as having occurred when the plastic deformation reaches a constant limit, such as that of 0.2, which can be different in a standard tensile test. Materials can either be ductile, meaning prone to failure, which also means they can bend due to their inner characteristics, whereas materials can also be brittle, which are actually prone to fracture without significant application before distortion. But keeping that in mind, there is a gray area where a material can either be ductile or brittle, yet it can fail due to many factors. This area or level of force is where a deformation actually begins, but when the force reaches a fractured point of the material, permanent deformation takes place. For example, a ruler can bend quite a bit, and when we let go of it, it comes back to its original state. But if we continue to add force onto the ruler, it will reach the fractured point and then it will break. Furthermore, engineers have a serious concern about materials that fail that tend to have ductile-like properties. Now, the main reason is that materials behave differently in different types of environment or situations. Like when a material is tested in a lab, it's tested in an enclosed, controlled environment. But when a material is exposed to low temperatures, for example, the material actually fails. That's why engineers and metallurgists need to test real-world materials in different situations. All real materials have some size of crack in them, whether it is a visible crack or a crack at the submicroscopic level. Now, there are two main types of fractures that can take place in a material. The first type is called brittle fracture, which occurs due to the loading and environment in which the material undergoes instantaneous propagation to failure of one or more cracks. The second type of failure is fatigue loading, where the initial crack may grow over very slowly over a period of time until one of them reaches a maximum critical size, at which the total fracture occurs. The fracture can happen due to many factors such as loading, geometry, material, and environment, which causes the propagation of the crack to reach a point where it can no longer propagate and thus the material breaks. Furthermore, a material is measured for its stress concentration, where in fracture mechanics it can be called as the stress intensity factor, or K. Also, a material is categorized in accordance to its characteristics of critical toughness, which is also known as critical stress intensity factor, or KC, which is done to materials by standard testing. Failure is defined as to when a material's stress intensity exceeds the critical stress intensity. Thus, there's a safety factor for failure that can be determined by the formula ultimate stress divided by actual stress, or Kc divided by K. Now, the values of K and Kc are for tensile loading, which is called mode 1. We can find a set of fracture toughness values, KIC, in table 6.1, where there are many commonly used materials. Most of the values of KIC are for relatively thick members, since the material at the crack root is approximately in a state of plane stress. Therefore, the values of KIC for plane strain are substantially lower than those for plane stress. That's why we use KIC for specific calculations where the thickness is not known or accounted for. In conclusion, fracture mechanics is very important in order to understand and study the different types of materials that are used in real-world situations. And we as engineers always need to find better alternatives for real-life problems. Thank you for listening.